Let's talk about input impedance next. We have discussed the concept of input impedance as it relates to electronic circuits in medical instrumentation 1. And probably it would be a good place to go back and take a look at input impedance and ideas of loading in electronic circuits. So the idea of input impedance and sensors is kind of a generalization of the idea of input impedance in electronics. And basically, input impedance is the measure of the sensor's ability not to interfere with the signal that it is measuring, right? So let me take an example, and hopefully this will make sense to you with this example. So let's say we are measuring the temperature of this object here. Okay, uh, the temperature of the object is T1 and its size is shown by the box that I have drawn there. Now, which sensor would you like to use to measure the temperature of this object? Would it be sensor 1 or sensor 2? Now, the sensors are at different temperatures compared to the object, and we want to measure the temperature T1. Which sensor would you like to use? Now, I wouldn't like to use sensor 1. Why? Well, for the simple reason that sensor 1 is of the same size of the object that I am, whose temperature I want to measure. So if I bring sensor 1 close to the object, the temperature, the heat, there is going to be a heat transfer, and the temperature of the object once stability is achieved would be T1 plus T2 over 2, right? So it would be the average of the temperatures T1 and T2. And what sensor 1 would have done is it would have interfered with the temperature T1 to a very large extent. And therefore, we will not be actually measuring T1, but we will be measuring an average of the object, of the temperature of the object, which is T1, and the temperature of the sensor before it touched the object. Now, if however I use sensor 2, what would happen? If I use sensor 2 and if I bring it close to the object and start touching the object, because because sensor 2 is very small, it will of course take away some heat from the object, but the change would be much smaller than it was for sensor 1. And therefore we can say that the input impedance of sensor 1 is very low and the input impedance of sensor 2 is very high. Therefore, sensor 2 has a greater ability not to interfere with the temperature of the object. Now, of course, you would also see that the influence of sensor 2 and sensor 1 depends on the size of the object whose temperature we are trying to measure. And that is the case, as you remember, in electronic circuits as well. You can have the input impedance high for a particular device or low for a particular device, but the influence on the circuit would depend also on the output impedance of the circuit. And so here, the size of the object whose temperature we are measuring. Now, I have taken the example of temperature sensors here because it's fairly intuitive to understand. But this idea of input impedance actually carries over to almost every other measurement.